Okay, so this is Eliza, Project Eliza session number 3. We're going to try something very radical. We're going to start with just an easy bug fix, which is adjacent to another thing that we have to do, which is we're going to try and give Eliza a private key to an Ethereum wallet. And we'll have to add some nodes for some basic functionality so that she can interact with that wallet and everything associated with that. And we'll also need to add the natural language side so that if someone says, hey, I just sent you something, I just sent you an NFT, she can actually go and check and get factual information. What we're trying to do is, when you ask Eliza an answer to something she has the data to, she almost always gives you the correct answer. When you ask her something she doesn't have any data to, she just gives you some bullshit. And if we can give her data, we can make her useful. And so I have a few different ways to do that, but running Eliza has been very expensive. And I think that means that we kind of have to point to some mode of economy first. If we're gonna build a self-sustaining agent, they have to know how to pay their own way to survive, especially as we get more decentralized. So I'm gonna pull up our latest Eliza. And this is kind of where we're at. And one thing we really need to fix first is this Discord API being exposed. It's just bad for my videos. It means I have to keep nuking my keys when I make these videos. And it also... sorry, did you fix it? You're fixing it?
I'm working on it right now.
You're working on it right now? Okay,
Yeah.
well, dang it, I was gonna... Okay, so you're working on it? Great, awesome. Well, that's cool. While you're doing that, I'll just skip on over to the next part, which is we'll need to add another field here that goes below OpenAI key, and that will take a Ethereum wallet key, and that will be another password field. And that way, when I do another video, it won't leak her private key, and people won't steal our NFTs. Cool. Okay, so where do we want to start? I'm going to start on Hack and B because I think there's actually 3 parts to this. I'm going to say there's 3 parts. First part, we'll come back to that. The first part is the natural language part. We'll just say Eliza Ethereum setup. I don't know, whatever. Natural language. The second part is going to be the API, right? We need some Web3 API. And the third part is going to be the user interface. You need an actual form. We need to be able to click the form and submit. So that's going to be the easiest part. And we kind of need that in order to test the other parts. So I'm going to do the easiest part first. And then we're going to do the Web3 part, which is going to mean we have to make a new node. We have to add an API key. We have to process that API key. We have to probably add that API key to our agents, entities, so each of them can have their own. That way, if if you're making an entity, you want to have it to have its own, like, I don't know, Morales or Infura, whatever accessing, and you can store that there. And then lastly, we'll have the natural language part, and that's going to be actually talking to Eliza and getting her to give you a private address and not. I mean, maybe we'll start with, we should probably proof of concept the NLP part, right, in Sandbox. I think that's probably reasonable. And make sure that we're not just like wasting our time, right? That a GPT-3 powered agent could actually take commands and reasonably interact with a person using their key without, 1, leaking their private key, obviously, and 2, like, not being totally useless or doing the wrong thing. Cool. So we'll do that, and then we'll stick it in the user interface because that's easy. Then we'll do the API, and then we'll come back and we'll stick this Sandbox stuff that we did, this research, into our some sort of NLP configuration. The other thing that we're going to have to do is determine, like, do we need to know about money? Are we talking about money? Does the user care, like, is this a conversation about payment, Ethereum, whatever? Because that might, there might be some stuff that we need to classify there. And then we also want to make a counter that says, like, well, I don't know if we'll get to that yet. But the next one will be to make a counter as people interact, so that she can sort of say, like, do I know this person? Have they paid me, or do they have a role, or are they just a guest? And if they are, I'll start to inject context that's like less and less helpful, because we really so what is our goal? We want everyone to get the experience. We want everyone to get hooked. We want everyone to like meet their new most helpful best friend. But if it's going to cost us hundreds of dollars a day to serve hundreds or thousands of users, it's just not going to be sustainable. And so we want to give people a taste and then have it naturally without having like APIs and all that, right in Discord, just do the stuff you use. We want you to be able to pay her like you'd pay like an artist making art for you, or a therapist giving you therapy, or whatever else you do, So that's kind of why we're formatting it this way, obviously. So proof of concept for the NLP part. What do we actually have to do inside of that? We're going to have to produce a command that checks the the wallet for any updates from a specific address, right? Did I, hey, I just sent you a payment from 0x whatever. Okay. Let's see. What else?
You could train it on to understand the context of somebody saying, hey, blah, blah, blah.
Yeah, we're going to get there. That's actually what we're gonna. No, that's actually the first part. That's what the NLP sandbox is. We're gonna get there right now. But first, we have to figure out what we're trying to actually do. So, what do we want to do? Brainstorming session. Well, we definitely want to produce a command that then goes to an API and calls a function and checks the wallet and says, "Did this person send me something?" Right? And it says, "No, I didn't get anything from you yet." We also want to, we're eventually going to want to be able to send stuff, but that's like super hard mode. Let's just be able to check the API and, read a contract first. Let's see. I think that's probably it for now. I think that's the main thing we're trying to do, is check for new things. Or check for things from... I just think check for new things. That seems cool. And we'll just try and sandbox that. That would be like an incredible achievement if we could just check the wallet and say, yeah, you sent me the thing. Then we could pretty much, the rest of it is all just engineering. So we're going to go to, let's see, what is it? Do you want to go to beta? Yeah. We'll go to our sandbox playground. This is kind of where we do all our real work. Personal. And that's our thing, right? Checks the wallet. Now, it could actually like call a Morales function. We could eval that, but we're going to erase that in a second. I just I need to put it there to process what we're trying to do. Task. Determine if the if we'll call it speaker has given us, well, we actually we have two things. We need to produce a command, but we also need to check if the speaker's already given us a wallet, or check if the speaker is giving us a wallet. And because I want to break these up into two pieces. And this might, I'm thinking of this on the fly, so it might change a little bit. Determine if the speaker has given us their public wallet address. Ethereum wallet address. And we'll say speaker agents. I just sent payment of 0.2 ETH from 0x. I'll just give mine, one of mine. Let's give Webba test account. Now, we're probably going to want to say agent. I'm just waiting for your payment, and then we can continue. Sexy boy. Just kidding. Just kidding. Okay, so and then we'll say we're going to make a couple of shots. So the way that it works, if you've never seen GPT-3 before, the way this works is that I am going to make a few different examples. And those examples follow an extremely rigid format. They're all the exact same format. And then I'm going to use that format, parse it, and then use it, downstream in my to then extract what it responds with, right? I get whatever it responds with. I extract that out of this whole thing, and then I can use that data. Sometimes we'll just use GPT-3 and take the raw response and send it back, and that's like a chat. But here, I actually want some formatted data in some way that I can then break out. LaserShark's been doing a super cool thing of like experimenting with JSON responses that include other kinds of metadata that a character or agent might need that actually get brought back. So you could bring back tone or emotion. We're doing this in Webiverse too. But there's kind of two parts to that. There's actually three. The first part is you demonstrate these tasks examples, and these are called shots. And this is called a multi-shot inference, right? We put multiple shots out, and then we ask it to complete another one based on this task. Once we've done that, we will run that and get a bunch of data. It's pretty expensive because this is a pretty long and complex prompt. But then once we have enough data, we'll feed it back in to a fine tune, and then we can make a 0 shot. And it just knows the task, and we don't need all of these examples. So eventually, we'll just have a very, way, way less tokens. But to start, we're going to have a pretty extensive and expensive prompt. Once we have about 20,000 to 50,000 assessments of this, we could run a fine tune. So at prototyping, the fine tune doesn't change as much, but at scale, it can have a massive difference on quality. And while you might play with GPT-3 and say this is kind of cool, the fine tune is can be 20 to 30% better, on scoring on a if it was getting 60% on something, it can get 80 to 90% on it. So anyway, that's some background. Let's get back to it. We have a task. Determine if we could format this a few different ways. We don't need this anymore. And we'll say use none if none was no wallet or no address was determined. Okay. And we'll say speaker's address. One thing I might be concerned with, and we might want to use string matching tactics instead, is that this is a very long string. And so we'll see how it does, but it might garble the address. In that case, we could probably just search for a 0x, right? Using basic string matching. We'll get back to that in a second, though. We'll just see how this goes first. And then we'll say agent. Sure, just send me a payment at, now we need some other address. And this is part of the skill we're teaching it is, don't just get any address that's in there. Get the address of the speaker or whoever that we inject in as later. I don't know, I'll just use this one. At, and determine that it's not the agent's address. And so again, if we have the agent's public address, agent public address, agent private key. If we have the agent's public address, we need to make sure that it doesn't get into the speaker's address down here, right? And so we'll probably need to, we also don't want to teach it that it's only looking for this string. We want to teach it that it's looking for any MetaMask string. And so I'm actually just going to go and do a Ethereum public key generator. There should be a like BIP32, BIP39, whatever it is. Can't do it here. Oh, I have to do it in code. That should just be a BIP39. Generate the mnemonic. So yeah, if you needed a private key to test this and you don't want to use MetaMask, I mean, I could just go into MetaMask and make a bunch of new ones. That's doable. You know, go here, create account. What? Sure, let's just do that. But if you just want a space, I wouldn't recommend using a website to generate your private key. But you can go in here and you can generate Ethereum private keys and public keys and pretty much everything you need. And this will give you privates, and then you can go and you can do the derivations, and you can get a public 0x address out of this. See, this is 0x right here. Just grab the first derivation. But I'm going to do this in MetaMask. Let's see, and we'll go down and just create an account, and we're going to say this is Eliza demo wallet, so that I don't make it her real wallet. And we'll create that. That's going to give us a public key. Now, if we want to view the private key, we could probably do that too. What do I have to do? I probably have to export the account or something. Account details. So this, we're never going to use this account because if I show this on the internet, this is totally burned. You never want to give people your private key, but just so you know, you can put your private key in, and I'm just going to pull this off screen, type in my password, and I do have my private key here. And we're actually, for this test account, I'll just leave it here. I will, I think that we should even just store this in, we'll just say new file, testdata.md, I don't know, docs, notes.md. Eliza test private key here. Do not use in production. Cool. So there's our private key. We're going to use that in a second. And then we also need the public key for that as well. Get the public key, and that's our public key. So never share your private key with anyone. You know it's a private key because it does not start with 0x, right? A public key does start with 0x. We can share that with people. Okay, great. So now we have the Eliza demo wallet, and then I'm also going to make one more. Well, I don't actually need to because I'm just going to use these derivations. These are just these right here. I don't have to make a whole thing. So Eliza demo wallet. Please send me a payment there. 0x83. And also let me know your wallet address so I can be sure where to expect it from. Cool. There's 2 shots. Let's just see how it goes. Agent. Once you've got 2 shots, you don't need to write the rest, really. You can just press the submit button. I will look out for the payment. And let's go grab another derivation. Here it is. Determinant of speaker is given. And then we also need a none case. Speaker. Hold on, just having some issues. Now this could probably like be solved just in a string match if it's all 0x, right? But we'll see. I think we're gonna still need something like this in a second. Certainly, it would be better if we could. And maybe this is like something where we want to check for a private key. And then we'll just say code nodes string check for private key. I'll make a note of that because we might just come back to that. That might be a better way to do it, right? But we're on this path. Cool. And then from here, I can say, I'll just submit. I'm going to remove these, and I'm going to set my stop code to be this little hashy deal. We'll say agent. Sure, just send me a payment at 08x payment set. Okay. So they did not give us the wallet address. But cool, that's our shots, right? So what we're actually going to put into an API prompt from here is you can actually just go and view code, and they give you the entire completion. You can shove this into Node.js and make this call. But what do we actually need here? We're going to need this to be more like agent prompt, right, or whatever. Speaker will be speaker text. This is kind of following the same patterns we did last time, where we're going to do dynamic injection of string variables into our prompt. Then we'll send it off, and that way it's always looking at the agent and speaker specifically that we're talking about, not just some agent and speaker, but it'll be Eliza and Moon, for example. So that would be like this: agent, speaker, and then speaker's address. So this is a way to do a basic data extraction, and you can do this on any kind of data. You could give this SQL data or tables or whatever you want, and it could extract a bunch of different data from it. And
will this basically establish like a one-to-one relationship between username and address?
No, we're going to have to do that separate. So, but it will give us their address, and then we're going to use that and store it to their value, like key value. And if we don't have an address, we'll run this. So how is this going to work in the bigger picture? If we don't know their address, we're going to try and get it if we're talking already with them about payments. If we have their address, we should probably validate it, or we should even run this and then make sure that we got the right thing and we're doing the right deal. And we could put a string matcher before this to make sure that it's got some 0x in it. But then we could, we should probably process that, because the failure case that I'm imagining is that they say, hey, I just sent you something from this address or to your address, and we have to make those determinations. So some of this stuff, it's like, do we do that in code or do we do that with AI? I think that AI is maybe overkill for that task. As I'm coding it, I'm like, I think I could probably just do this with string matching. But
or something like a command line, maybe. Command line-esque.
Yeah, I'll show you the interface. You haven't seen the interface yet. That's a big part of it. We have an
I
interface.
watched the video.
Oh, okay, cool. Then you've seen the interface.
Yeah, the brains.
Yep. Okay, so speaker, we'll say speaker's address. So the way we would template this out is we have agent speaker, we get speaker's address, agent speaker, we get speaker's address, and then we'll replace that in code, and then that should be fairly consistent, right, for this kind of task. And I'll save this because we might use it later. But I also think that we could probably do this exact same thing, just not with AI. And the reason we would do that is because AI is really expensive. This would cost us quite a bit more to have all this going every single time we want to deal with this kind of task. And I think we could probably short circuit it. Another thing I do is like I'll do a short circuit that maybe is getting 80% of the time, and if I'm not sure, I'll run it through something more complicated like an AI thing. Also, the short circuits are much faster, right? They don't have to go call anything else. They're all internal. So that looks okay. This is a viable prompt to do our task. We proved somewhat that it works. I could probably even do it even with these, like these. I'm still waiting your payment. Speaker. Sorry, I sent it just now. Please wait for it. My address is boom. Task. Oh yeah, right. Task determine if speaker. That way they're all uniform. Are they? Did I do it right? Speaker, 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 speaker. I think so. And then speaker's address. Cool. So this is what the actual prompt will look like. This is a finished prompt. In fact, it's probably too many. I could probably get rid of one of these shots. Right. Probably too many shots. I think 4 is enough. And I have 2 failure cases and 2 success cases. And I have 1 success case where she recommends her own wallet, and I have 1 success case where she doesn't. And then I have, this will be my example case, where, I mean, we can test this here, but I don't even think I need this, right? I could probably just do like that. That's my prompt right there. So it'll inject all the stuff. These are kind of the shot examples of our task. You can see it's outlining what the task is exactly. Then it will inject the names. It will inject what the agent said, what the speaker said. This is wrong. No, it's not wrong. But we need to think about this because usually the agent is waiting for what the speaker says. So it's usually speaker agent, like call response. And we're flipping this because we're trying to contextualize whatever the speaker said within the context of whatever the agent said, if that makes sense. So we're getting agent speaker task. We might not even need the agent, right? Like what if we just needed the speaker and we're just doing something like this, So I'll save this as get address from speaker agent from agent speaker. And then we're going to have to refresh because their UI is horrible. And we're actually going to remove these agents. And the reason we would want to do that is because let's see. We don't we want to save tokens as much as possible, and we probably don't even need to know our own. All we need to know is that we could say like agent's wallet you know, agent's wallet address is, and then give the agent wallet address. Like, that would make a lot of sense. But I have a feeling we could also do that in an LP if we know the public address. So here we have another kind of sandbox prompt, right? And instead, we're just doing the speaker, determine if the speaker has. So this is a single extraction, and we'll save this. Whenever I go to save, it like saves over my preset. F address from speaker. So that's what we're trying to do there. In terms of parameters over here, you'd usually want to have your temperature pretty low for factual extraction. You're going to have, I'm using the stop sequence this. It can be anything you want, but I just like the triple hash because it's unlikely to show up in regular conversation. We've gone over what all these do. Top P and temperature both play together to control creativity. Top P basically controls the diversity of words that can be sampled from the corpus. Basically, most words are like down here, and some words are up here. So this is like, yeah, it might say like, I don't know, Blade Runner, right? That might be something that's over here, not so common as like hello. And then you have temperature. That's going to be kind of the random variance of sort of potential completions. And this is creativity. If you turn this up, it gives you a lot more likely types of completions. Something to know is that AI is not random. No AI is random. It's all deterministic. We use seeds and randomness in various abstractions to create the sense of randomness. But we actually control the randomness and distribution, and we can repeat anything that was made in this AI could be repeated again if you knew the seed. But we don't have control of the seed here anywhere, you see. But we do have control of like the temperature. And if I turn the temperature all the way down, and it's not creative at all, it'll almost always give me the exact same deterministic result. Just because like I'm sort of forcing it within such a confined space, especially if I turn the top TP down to like 0.4. I can guarantee that whatever I press here is going to come the same every time. Then the other things are frequency penalty and presence penalty. Gives you a little tooltip. So if you already have text in here, frequency penalty will prevent you from repeating it. A big problem with a lot of models, especially the previous generation of this, is that they could repeat themselves over and over and over, and that's pretty bad. And then presence penalty is going to so there's basically how much they've this is like decreasing verbatim, and then presence penalty is more the overarching decreasing of like topics. So a higher presence penalty is going to force it into new topics quicker. And you use these two to kind of control like the micro repetition and the macro repetition. And if you put your finger over the tooltips, you can see kind of what they say. It's obviously a pretty complex mathematical thing that we're like turning to a knob and then creating kind of an abstraction for quote unquote creativity for. But that's kind of how that works. So typically though, I'd have a temperature of like, I don't know, 0.2 and a top P of 0.5, I don't know, whatever, 1. I don't know how it'll handle these wallets. It might be pretty bad. So we should actually try. Well, I would hope that from speaker text it gave me none. Of course it did. Let's say I'll just delete this real quick, and we'll say, and just to make sure that I got it right, looks like it's right to me. So it's pretty good at repeating the exact same string. That seems pretty good for like getting the address from the conversation. But the problem is it's really expensive. So how do we get this address in Thoth without having to do all this crazy AI? I think that might be a better way to approach it. Well, there's a few ways. I'm going to make a new spell. Great. Okay. This is Thoth. We're in a spell. We definitely want a code node. Code nodes are going to let us do pretty much any kind of JavaScript we want to do in here without having to create a whole new node. For an API call, we're going to probably have to go make a new node, that does that thing. But for just like arbitrary string stuff, this is actually totally fine. And so there is a text editor here. It's full Monaco. Doesn't have Copilot yet, but it's got everything else. It would be great if we just added our own AI into here. We could get Copilot. So we're going to add just, I don't know, input. Why don't we say speaker, speaker text. We'll just say input for now. It's fine. Output. And then we're also going to need agent public key, because we're going to filter that out. We don't want to accidentally get that in there. And I'm just going to do snake case for these kinds of variables, because Python people like it. And let's call this get 0x, right? Okay. Simple enough. We'll wire this output here, and we're going to use a default, and we'll say moon. I just sent you some ETH from my wallet address, which is 0x7a. Cool. And our agent public key, we'll make a string variable here for now. And then I'm actually going to save all of these as like units that we have a subspelling, so we can bring these into these graphs into our bigger graphs, like subgraphs. We call them spells. But I wasn't really able to get it to work very well. So for now, we're just going to build these here, and then we'll probably transfer some of the pieces over. Cool. So we've got a string variable, and that string variable should be our oh, well, we blew it away. So we should go get it again. Oh no, I wrote it down. Great. That's why I wrote it down. Variable. And we'll say Eliza's address. I don't know. Agent address. Right. Better. We can also receive from playtest, but if we do the default, then it just does this, and I can just press send. I don't have to keep smashing it out. Okay. Output, and then we do want to send this to playtest so we get the response. So this takes an input and a public key. What do we actually have to do in here? Let's see. Eliza, are you there? Let's see if it runs. I think it's gonna have no. Can you write a function that determines if a string has an Ethereum address in it? Can you write that function in, I think that's cool, it's in regex. JavaScript? Actually, that is in JavaScript, isn't it? Function. Yeah, I'll take that. Fine. Using AI to write AI. Has Ethereum address. That's pretty cool. I would not have figured that one out quite easily. I would have done like a ugly 0x string match check. I guess I should say regex, but anyway, I learned on the internet. Okay, we have Ethereum address. We're gonna destructure inputs so that we get the direct inputs, which will be input and agent public key. Now we'll say const has agent public key equals input dot includes. I mean, you can't really. We could to lower it. That should work, right? Yeah, it should work. To lowercase. Dot includes agent public key. And if it includes the agent public key, well, how should we do this? We could just ignore the message or assume like, no, they're not serious. But I could also imagine a case where I'm like, I just sent 2 ETH to your wallet from my wallet. And so, excuse me, what I think we're going to do is just do a little bit of NLP here. And we'll say if has agent public key. We're also just going to say let eval input equals input. And there's a lot of ways we could write this. This is kind of the quick and dirty way. Dot replace. And what do we want to do? We want to replace agent public key with your wallet. Cool. Nice and simple. And then we can do the eval now, because they might still have another key in there. So const has speaker public key equals has Ethereum address eval input cool. Next we need to what do we want to do? We want to extract the speaker public key. Let's see. If there's no key, return output null. Right, so if has speaker public key, return output is null. Great. And then we want to extract the speaker key. Let's just go back to Eliza really quick. I should just open. It's so freaking helpful. I just need to make another one. Can you write me a JS function that extracts any Ethereum addresses from a string? Extract Ethereum addresses. How many addresses can that extract? I think it's just one, right? Can you rewrite the function to extract the first one? First address. Sorry, guys, I'm not that good at code, right? I've like totally started leaning on this. Here's the code for that. Almost. Can you repeat that? There we go. It got garbled in the send. Okay, that looks good to me. Extract first Ethereum address. I should be better at regular expressions, but I'm good at AI, so who even cares anymore? Cool, and we'll say const speaker address equals extract first address eval input, and then we'll output that, and we have our get the address out of the wallet. Now what's cool about this is this doesn't cost us any money. So a lot of things that can be easily solved with AI can also be solved without AI, or can be even solved with cheaper AI, or could be solved by string, like cleaning it up and then getting what you need out of it and then doing a little bit of AI with very few tokens. But as we get into this stuff, the name of the game is going to be lowering costs, which also makes it faster. Okay, so we're going to output the speaker address. That would probably be better if that was right. The AI wrote it, so it's got to be correct. Can we format it? Yeah, nice. And I'll just export in case it nukes. Cool. What happens if you run? Null. Nothing happens. Okay, but why would that be? Okay, so let's see. Let's figure out what we did wrong. Gotta log the inputs, obviously. Key, good, agent, public key. As agent public key. Oh yeah, also this needs to be to lowercase. Select that and that. Turn output null. No speaker key for eval put the console here so we can actually see the input. And output of the universal component was input text here. Let's just that should show me. Let's just set a result. Usually I should be able to see the logs here. I guess it's only showing me the output though. Or it's a little hard to contextualize. So we'll just have a result. And we'll say let results. Is that we'll return no speaker public key. I guess I don't even need the result. I can just do like this. I'll input and then if speaker address turn output no speaker address. All right, let's see what's up. Test. No speaker public key. Input text here. Okay, so it's just giving it garbage. It's not giving it our thing at all. Let's see what happens if we result the output. Okay, let's check if our regex work, right? That should bring us back. lose a save? You're kidding me. Alright, well, that's fine. We know what we need to know. Has Ethereum. And then we will say return output, extract Ethereum address, eval input. That sucks. Test. I'm surprised it's not working for me. Okay, well, we can do this quick and dirty way. Let's see, split eval input into lines. If the line starts with 0x, it's the address. Right? So we'll say const split input equals eval input dot split. I'll split it by space. And for line const line in split input. And we're going to do if line dot includes 0x return output line. I think that's right. Let's see. Now we need some crazy fancy regex. Fascinating. Let's just put the output to be the input really quick, because I don't know what's going on here. Okay. So it's using default. I see. I didn't see the spell. Cool. So now it's doing that. But let's check this code. Turn bad. Output false. Let's just do this over here. JS. Write a function that in JavaScript in JS that takes a string and turns all Ethereum wallet addresses as an array. function get Ethereum wallet. Are you fucking const? Okay. Tests cases function test. Let's see. Const test wallet address. Great. Const is wallet. Node code.js. Really? I just run it. Oh, it just doesn't know where it is. What am I doing? There we go. Okay, so it definitely works. Should work here. It's the same function. Maybe the formatting got messed. Okay, but we're gonna do this a little bit different. We'll say function worker. Takes those inputs, calls get Ethereum wallets. Let's see, gonna get wallets. Wallet address matches, remove it from the array. If any more wallet addresses left in the array, return the first one. Okay, great. Seems right. And we'll say for wallets, if wallet's length equals 0, return wallet 0, otherwise return null. Also, probably want this to return output. I love Codex so much. Okay, that's good. We'll format that. Probably don't need that. We do need wallets to come in from input. So now we'll do same test case. Test worker function. Try another test wallet address, not a 0x. Nope. That should be her wallet, and then we should have my wallet. And we'll say const test result 3. Okay. Should be good. And then we run it. What? Nothing. Worker takes input. Start test. Say, oh, I didn't log the results. That would help. Okay. Right. There we go. Okay. Output null. We test the 0x. It does not believe the 0x is an address. That's very odd. Oh, right, because it's also using the tester wallet address. So we'll say agent wallet address. Agent wallet address equals 1. And then we can replace. Now we have a proper test. And we say, okay, the first wallet output 0x00. Cool, great. The second wallet outputs null. And the third wallet outputs 07xa, which is the one we're looking for. I also think we should return null on the 0x address, or 0x 0 address. Yeah, like that. You want some formatting? What do you want? Do you want a conditional? Probably. Okay. And we'll run that one more time. And now outputs null for the 0x, outputs null for the artist, and outputs the wallet for the one we're looking for. Great. Format that. I don't know why it doesn't want to format with. TypeScript. Yeah, okay. TypeScript and JavaScript. And then we can take that, we can throw that in here, and now we have a proper thing. It should work. I don't know what's different. Test outputted false. This outputted false. My address. It didn't save, did it? It must not have saved. Okay, let's try that again. Okay, output the 0x. Great. Now we have a little node that extracts a wallet address. Very simple. But what I can do is I'm just going to save this. I'm going to export the spell. We're going to drop this in our ELIZA stuff. It's a unit test. And yeah, sure, whatever. Okay, that'll do that thing. Cool, let's go back here. We figured out the proof of concept of extracting. We're not going to use the OpenAI sandbox. We're going to use the traditional techniques. It's a lot cheaper and faster. The other thing is that the GPT-3 stuff adds a half second of latency. Got to go there, get processed, get back. Sometimes up to like 2 seconds. It's variable. And this is like, instant. Next we, well, what do we actually do with that? Now we probably have to do some crazy GPT-3 to like, once we actually have the information. But I think we'll do these two things, and then that will let us do this thing, and then we can do the like putting it all together into an AI agent part. Okay, so for the user interface, we have to add the public address and private key fields. I'm just gonna go and look and say, look, my entity already has Discord private key, but we're not going to worry about the Discord. We're going to worry about this OpenAI key here. We're just going to add a couple more fields below it. I know it's ugly, but we'll dress this form up. For now, it's a bunch of data fields. Nope, not going to be in this project. It's going to be in Thoth. We'll just search.
If you want to make an PR turned over.
Ooh. Yeah.
And you can just use the same format.
Sure. Let's see. That's at the Nexus City / Thoth. We've got a billion versions of this, but this is what we're using now. Hide entity secrets in editor. Change that to a password field. Brilliant. Looks good to me. Fix Mac OS and prevent default enter. Oh yeah, because when you press enter on the key,
on the API key in the play test, yeah.
I'm not gonna pull this in right now because there's a slight possibility it breaks my thing.
Yeah.
But but that looks very promising as well. So at least we got some Mac OS fixes. Okay, so good. While we're here, we might as well just git pull Nexus main. Update that. And in here we have a form label. It's kind of a search for it. We're in the entity window, which is the code for right here. And we want to add the OpenAI key. And I'll just refresh this so that now my keys are hidden. Let's make sure that took effect. Look at that, Discord API, OpenAI key. Can't see them, great. So right below that, OpenAI key, we'll just say Ethereum private address, and we'll say set private address, and then we'll say Ethereum public address. Now the way that the EVM chain works is when I say Ethereum, what I'm talking about is any EVM chain that could include Polygon and other chains that use the same key generation spec, basically. So, or whatever basically we can get supported by Infura or Morales or something like that. So we're going to call it Ethereum because it is an EVM, you know, it's a BIP39, whatever, mnemonic based address. But we can also, we'll probably use Polygon because it's a lot cheaper. Let's see, so set public address. Maybe we'll say set ETH private address. Now we're going to have to go through and we're going to have to add these kind of to everywhere where we do stake calls. And this is a little messy. This could probably all be a, you know, more singular state object, but that's what we got right now. So we'll say const ETH private address, set ETH private address, and then const public. It's actually a private key, right? We should probably call that a private key. So it gives me a hard time. Private key. Set ETH private key. And ETH public address, which could also be a public key, but I'd like to make it clear that we have the private key and public address. Okay. Looks good. Now let's make sure we got that going both times. This is going to need to be ETH private key, and this needs to be ETH public address. And then we'll put it down here, ETH private key, ETH public address. So that's going to submit this to the update. Let's go look and see where else we are doing this. We're going to probably have to change the data model as well as the REST endpoint. Easy enough, just copy and paste. It's nothing too hard. At this point, we can do. Oops. Grab the wrong two lines. So if you wanted to add a variable to the database, or to Thoth or something, you know, it's pretty much just adding something to the entity. You've got to add this to the entity attributes, which is a type thing, and then you got to go down and add it to the actual thing here. I don't know, I'm kind of just copying and pasting, right? At the private key, public address. And let's just go through. We've got some fake data that's probably dead. I don't think we need to worry about that. Put it in. And same deal. Just tab it out. Great. This is where we actually get the OpenAI key, and this doesn't matter. I'm not using default record stuff. Okay. Looks good to me. We are going to have to go... Now, there's a couple of ways that we can change our database. The way that you could do it is wipe your database and change everything, and with seeders, and this is SQLized. It can create a new database and populate it with the right structure, and blah, blah, blah. But that seems kind of horrible, and I've got some data, and I don't want to have to go clean it and stuff. I just want to like add some add some fields to my tables. So the way that I do it is I have tables plus. I used to use MySQL too, and sometimes I use that, but sometimes you just like need a GUI because your head hurts. And today is one of those days. So I have a Thoth connection. You can see localhost 5432 Thoth. I don't know what the password is. It's like Thoth underscore something, but you can find this in the Docker settings because this is all initialized with the Postgres Docker container. We could probably figure it out if we're curious. What is the password? How do we connect to this thing? It's good to know. In the is it the server? Probably, yeah. In the Docker Compose, I would assume. You can see there's a Postgres here, and the password is Thoth underscore default underscore password. This is all the information you need to put into your client in this Docker Compose. I already have it set up. I connect. I go to, well, where's this going to be? It's on entities, right? This is the entity model. We're adding some details to the entities. Entities are standalone. Well, they're actually just database entries, pieces of data, but we have an entity runner, which will look and say, is anybody running this entity right now? And if nobody's running it, I'm going to run it. So that's how we're doing it right now. Let's see, we've got all this stuff going. We've got our entity table. You can see the structure right here. We're going to view the structure. And you can see we got a ton of fields. These fields correspond to our model here. We're just going to add a couple, right? What do we need to add? We need to add a field for F private key. Right? That's the one. And we also need to add one for F public address. And we need to make sure it's spelled right, and we need to give it a type of text, because that's what we indicated in our model. Is nullable? Yes. It doesn't have to have a value. Does it have a default value or something? Nah, doesn't matter. You save it. That's it. Now we've modified our model. Now if we go and look at our entity, you can see it's all right here. All the details, and those are somewhere in this really complex entity table. Cool. And that should be all there is to it to add this awareness. Let's go look in our UI, see if it changed. Bugs? What kind of bugs we got? Oh, just hasn't started up yet. Ethereum private address and I want that to say private key. People to know that it's a key, not an address. Ethereum private key. Ethereum public address. So let's go check on Eliza's. Not that one. There we go. Notes. Ethereum public key. Oh, the public key doesn't need to be Ethereum private key public address. Cool. There you go. There it is. And then our private key. Where did we put it? Go right here. Okay. So I'm going to take a quick bathroom break, but first we're going to do a little recap. we made the user interface part have the public key and private key stuff. That is now tied to the entity. We have to expose private key and public key to the entity. I could have done this a different way and just given the private key in the graph. But I feel like that makes it not as shareable. I feel like it's good to have your private setting stuff in your entity for now. So I think it's a fine way to do it. It's kind of adding what we're already doing. But what we need to do next is expose the private key and public key to the actual graph, right? So, we can add that to agent info if we want to. I mean, that's kind of cool. We don't need that information. Wondering how we get the agent info. We could do the agent destructure and we could add private key, public key to that. That seems kind of cool. I wonder if it's overkill or if we should make it optional. I think for now, since this project is simple and we can always refactor it later, we're going to add these to the agent values, and we're going to destructure them, which means that in our main spell, we have this thing called the input destructure, and it looks like this. And it passes a bunch of, all of these nodes are actually going to be turned into a single blue agent node in the new version of Thoth that we're working on. But you can see there's a lot of, all these are individual outputs of pieces of data. So we're just going to add the private key and public key here as pieces of data that can be exposed in the graph. And those will get populated by the entity. So the agent itself, when it's running, will tell us what those are. We can use those and pass them around. And that way, payments will be pretty integrated into this for now. Maybe we'll break this out. We'll say like agent destructure, and you can, say like I want these or checkboxes or something like that. I don't know, whatever. Cool. So, good. Let's just check and make sure that these saves work, because sometimes they don't. Here's the private key. Here's the public key. And let's update to that. Nope. Definitely some kind of view bug. No, I guess not. It's there. What am I saying? I was just looking at the wrong one. And let's go validate that in the in here. And let's go down here. Entities. Oh, they're at the bottom back. Okay, look, and there you go. You got the public and private key. So, okay, I'll be right back in 1 minute. Expose to, let's see, what do we got to do? We have to expose the private key and public key to the entity. Great. We have to let's see. Well, once we got that, we've got to determine if a message contains in our main loop. Solved, right? Now I've got to handle the message. And how are we going to do that? Well, that's how we're going to do with some web, by checking contents with Web3 API. Now, we're kind of statelessly checking. So we're checking for assets. The way that we're going to do this, I think, is do event received assets, where we actually, we maybe either make the agent live listen and add to its database, or we could even just statelessly like diff, hey, I'm going to go check my wallet, nothing new, or so, I don't know. We'll figure that out. We can also create a separate wallet handler loop. So the agent can run in a loop and can perform actions in the loop, and it can then queue those for itself. It can even call its own graph and all that stuff. So what we're going to need to do is let's actually solve the private key to the entity, and then let's implement Web3 API and perform test check, and then store data in DB for user, and then recall data from DB for user using our event system, and then check if diffs, new, etc. And then we're going to add basic scoring system for user. Subtract tokens or subtract points. You know, like payment equals points. Payment points. Injection of context at low score. So we might init a user at like 5 points. They can talk to Eliza 5 times. Beyond that, she'll start to say, "Hey, I'm blah," and then at -5, she like stops talking to them completely, totally turns off, something like that. So that's what we're gonna try and get done. If we can, if she gets paid, great. I'm gonna take a 5-minute break. So I'm gonna pause this recording and then I'll make a second recording since this one's pretty long. And then this is what we're going to accomplish. And then we should have an agent that we can pay some money to. We'll probably do this on testnet for now, just on Rinkeby. I can send her some token. She'll check for it, and then maybe she'll talk to me if I paid her money. So just like a little simp bot, basically.